Can you say hi to the video?
Sure. Let's see when it... All right, we are live now.
What's poppin', guys? Today...
Is that how you want me to start this video? What's popping, guys? Today we're going to learn about angle, side, angle, and angle, angle, side. So, just in case you're watching this and you're not in my class and don't already know I'm crazy, that was prompted by a student. Okay, so we are on 4 or 5, and we're going to do a couple problems together. Then you're going to do a couple. Let me try that one again. A couple of problems on your own. All right. Now, we have a little cheat sheet here because we know that this worksheet is about angle, side, angle, and angle, angle, side. Now, I want to talk about the difference between those for a minute because I asked my second period class and they didn't have a clue. So I just want to make sure everybody understands the difference, okay? So if you've got two triangles and you know that this angle is congruent to this angle and this angle is congruent to this angle, right? If you know that this side is congruent to this side, that is angle, side, angle, because the angles bookmark that side, okay? Angle, side, angle. Now, if you've got two triangles, and you know that this angle is congruent to this angle, and you know that this angle is congruent to this angle, right? But you know this side is congruent to this side. See how that side is not between those two angles? Everybody see what I'm saying? So this is angle, angle, side. So both of them you're using two angles and a side. The difference is this side is touching both angles. And on this one, this side is not touching both angles. Do y'all see the difference? Okay, just want to make sure y'all understood that. Now, on number 1, it says write a flow proof, but we're only going to focus on 2-column proofs for just a little while. So we're going to change that to 2-column proof. So we're going to write a 2-column proof to prove, here's what we're trying to prove, triangle JKN is congruent to triangle MKL. So we're going to set it up. Statements on one side, reasons on the other. All right. Now, we'll always start with what they gave us. So what did they give us here? They said angle N to angle L. So angle N is congruent to angle L. And how do we know? It's given. So our reason is just given. Boy, I made a huge G. That G is ginormous. Yeah, okay. Okay, and then they told us that JK is congruent to MK. Segment JK is congruent to segment MK. And we know that because it was given. So we've got this angle is congruent to this angle. And we know this side is congruent to this side. So we know an angle and a side. And because we can cheat a little bit, we know this worksheet's about angle, side, angle, and angle, angle, side. So we need two angles, right? They didn't give us anything about another angle. What do you mean? Uh-huh. Not reflexive. Not reflexive. This is different because it's not a segment. It's an angle. So, if you couldn't hear Hudson, he said K. Now, we do have a little issue here. We can't call two angles the same letter. So, we can't say this angle's K and this angle's K. We can't call them both K. So, NKJ, angle NKJ is congruent to angle MKL, right? MKL. Now, how do we know? What's our reason? It's not reflexive property. That would be the case if it was a segment they shared. This is a different thing, and it's about angles, and it's something you learned. Definition of vertical angles, or vertical angles theorem, or if you just put anything about vertical angles, I'm okay with that. Okay? So technically you would say vertical angles theorem, but I don't really care what you put. If you tell me vertical angles, I'm down for that. They are vertical angles. Vertical angles are those angles created when two lines cross. The angles across from each other are vertical angles, and they're always congruent. So now, based on that information, we know these two triangles are congruent. We know that triangle JKN is congruent to triangle MKL. How do we know that? What theorem? Yes, now let's talk about why Jordan knew that was angle, angle, side. Remember, if it's angle, side, angle, bless you. If it's angle, side, angle, we know this angle and the side between them. Right? That's not the case here. We don't know the side between the two angles we know. We know a different side. That makes it angle, angle, side. Does that make sense? Okay. That's it. We're done with that problem. With that one. All right, let's do number 2. Was I confusing on purpose? Maybe. Maybe a little bit. Okay. 2-column proof again. Statements on one side. Reasons on the other. Now let's look at what we are trying to prove this time. So this time we're trying to prove that AD is congruent to CD. So we want to know that AD is congruent to CD, right? Now those aren't triangles, but they're parts of triangles. So if we can prove that the triangles are congruent, then we can prove that all their parts are congruent, right? So we're going to prove the triangles are congruent first so that we can turn around and say, oh, hey, look. If these two triangles are congruent, then all their parts are congruent, right? So what'd they tell us? AB is congruent to segment CB. So that's this and this, right? How do we know it? It's given. And then they told us that angle A is congruent to angle C. And how do we know that? It's given. So we know an angle is congruent to an angle. We know a side is congruent to a side. Y'all know we're going to have another angle, right? Because today we're doing angle, angle, side, and angle, side, angle. And both of those take 2 angles. And we only have one so far. So our next piece of information says that DB bisects angle ABC. Now that was given also. Now what does that mean? What's congruent? So bisects means cuts in half equally. That's what bisects mean. So if BD cuts this angle in half equally, what does it create there? 2 equal angles. 2 angles that are congruent. So that means that this angle right here and this angle right here are congruent to each other. So angle ABD, angle ABD is congruent to angle CBD. And what's our reason behind that? What's your best guess on our reason? So close. Definition of a bisector.
Wait,
yeah, definition of a bisector. You get the right word. And once again, y'all, if y'all say anything about a bisector, I'm down with that, okay? If you don't come up with a definition, if you say bisector theorem, I'm okay. That tells me you know where it come from, even if you didn't use the right terminology, okay? That was an amazing guess on your part. I'm so proud of you. Let me say this out loud so if your parents ever see this, they'll know why. I am so proud of you, Trenton Matthews. You did so good. Okay. Huh? I am wearing my leopard jeans. Y'all see them? I'll show them off in a minute. Okay, so now, what does that tell us? So now we know an angle and an angle, right? So, based on angle, side, angle, do y'all ever write something and say something completely different?
Yes.
I just said angle and put an S. Like, that doesn't even make sense.
Or
Okay.
say something but like spin it off, right?
Yeah. 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 Or just leave out things completely. Okay, so we know that triangle, ABD, is congruent to triangle, CBD. Those two triangles are congruent based on angle, side, angle. Now, remember, that wasn't our end goal. Our end goal is that these two are congruent. But since they are part of those two triangles, what do we know about them? AD and CD, segment AD and segment CD, are congruent because of, does anybody know this reason? If y'all come up with this, I'm going to be so amazed.
Something like
We talked about it, like probably Friday. It's a string of letters.
CP.
CPCTC, which stands for corresponding parts of congruent triangles are congruent. CPCTC. So, corresponding parts of congruent triangles are congruent. Corresponding meaning the ones in the same location. And then y'all know what congruent means. Right? And so we're done with that. That's it. We proved it. And y'all know we only had to come up with like 2 things on our own. Everything else they gave us. Right? We're not going to worry with doing number 3. So now you have your assignment. So 4 or 5. I'm making life easy on y'all today. Number 1. Number 2. I do want you to do a 2-column proof, not a flow proof, okay? So on both of them, you're going to do a 2-column proof, not a paragraph proof, not a flow proof. You're just going to do a 2-column proof, okay? So someone asked me this morning what a paragraph proof is. It's just when you write it in words, like in a paragraph. And the easiest way to do that is to write a 2-column proof and then use that to write your paragraph with. Kind of like if you're brainstorming and you write an outline in writing, it's the same thing. So we will eventually write paragraph proofs, but I want us to get real good at these 2-column proofs before we start doing that. So, because if you're real good at a 2-column proof, you can do a paragraph proof no problem. Because all you're doing is taking that information and putting it into sentences. Okay, everybody good? You know what you're doing? So your assignment, you will turn it in online on Google Classroom. You will snap a picture and post it on the assignment. If you haven't done that for 4-4, you need to do that, okay? Alrighty, I'm going to stop our video in this stream.
And subscribe. Check out the
I solely should.